Okay, hello everybody. Welcome back from your winter break. I think everybody is very anxious to know what we're going to work on this semester, and it's pretty much everything that has to do with creating the classes. You've always used methods from different classes, like the string class, and you've used methods such as substring, index of, etc. But how do you create the classes? And that is the question. And that's what we're going to start doing for our third quarter. It is very important that we understand what is a class, okay? And there are many different ways that people understand classes, but maybe it is a better way to understand it, kind of like a little factory, okay? So what I'm going to do is that, let's say that we are, and I'm going to use the student case study so we can understand what they're trying to say and what the book is trying to tell us. Okay, so let's say we have a factory. Okay, now this factory is going to be, let's call it student. Okay, I'm going to call it student. Okay, so for us, this is going to be, like, the factory is going to be the class. Okay, so we're going to call it the class student. Now the student class, or the student factory, creates or builds students. Okay, so in this class, this kind of like builds or creates students, and these students are going to be objects. Okay, all these students. So we can have made out of this factory, we can have student 1, student 2, student 3, and so forth. Okay? Now, each of these objects was created from this class. And these objects are very, very important. And you have to remember the three characteristics of an object. The three characteristics is every object has a behavior, so this object will have to behave depending on the methods that we create, or the methods that the student class has. It also has a state. Okay? Now every object has a state. And as the book says, which is another way of saying that any particular moment, its instance variables have particular values. A state means that this student will have some characteristics inside, and it will have a name, and it will have some test scores, and you will be able to modify those test scores using the methods, okay, or using different behaviors. And it has an identity, and the identity is unique. They can have the same values. Two students can have the same name, they can have the same test scores, they can have the same values, but it has its own identity. So this is very important, understanding what an object and the difference between an object and a class. Okay? So S1, let's say our object, this object S1, has some characteristics. Okay? In our case, a student, for our example, it has a name, okay, and it has 3 test scores, right? So these are values that every single student has, okay? It is important that those values are held by each of the objects, okay? So when we create them, when we create a student object, we have those values. It has a name and 3 test scores, okay? Now the behaviors of each of the students are explained, or they are created inside the student class. So inside the student class, we have the behaviors. Okay? So we're going to have a couple of things that we can ask the student to do. One of them is that we can set the name. We can set the name. We can also get that name if we need to see what is the name of an object. We can set the score. Okay? We can also get the score. We can get the average. Okay? We can also get the high score. And there's a very important behavior or a method that we should always include in every single one of our classes, and it's the toString. Okay? Now we have to create all these methods inside the student class. These are behaviors, all the behaviors. Now each of these methods will need some parameters. Okay? Now these parameters are very important because they're the way that the method works. If you're going to use the substring and you do not use the correct parameters, the method is not going to work, or it will work incorrectly. Okay? So we have the class and we have the methods and we have the behavior. Okay? Now if I need to call or I need to use any of these methods for one of my objects, I can say s1 dot set name, okay, and use the parameters, okay, use the parameters that are needed. Now here is where we start talking about the difference between actual parameters and formal parameters. The formal parameters are the ones explained or designed in the method. So if the set name requires a string, okay, this is a formal parameter. When I use the set name method and I call it and I say this is Nick, this is the actual parameter, the one that I'm passing. So that is the difference between actual and formal parameters. Now these objects, remember, these objects can be created, okay, using something called a constructor method. We will see that in a moment with the class template. But for every single class in Java, or for every single object, you need to follow the rule or the basic configuration of how to create an object. And it's using a class, okay, the name of your object equals new, the class, and the parameters needed for the constructor. Okay? In our case, in order to create a student object, we have to name the class called student. Okay? Then we say it's s1 equals new student. Okay? And the new student requires some parameters which we will see in a moment. So this is basically how classes work. Every single thing in the world can be handled through objects in classes. Let's say you're playing a new video game. Well, if you're playing, I don't know, FIFA or any other video game, then you have a class that it will handle the players, okay? And those players, each player will be an object. Let's say each player is an object, and each player has a list of all the behaviors or all the methods that can do. Okay? So we will talk about that more in depth when we get into other topics like hierarchy and polymorphism, where you will understand the relationship between those classes. So for now, we're just working with a class, which we will use all those methods from a test class or a test app. Okay? So basically, this is how classes work. What we're going to do is that we're going to work with the case study that you have on your book. Okay? Now the case study shows the student class. Okay? I'm going to have it over here. So you're going to have to, from the student files on chapter 6, you just drag and drop or create a new project called case study. Drag and drop the student and the student app files and open the student file. Okay? And here we are going to understand the template, and we're going to understand the structure of the class. So first of all, for creating a class, you need a name. Okay? Most of the time it's public, okay? Because it's going to be visible to other classes. So we have our student class. Then we create the instance variables that are going to be needed for our class. So each of the objects from the student class will need a name and 3 test scores. So here is where we create the instance variables. It is important to understand that private means that these variables can only be modified within the student class. You will not be able to modify these variables from other classes. Then, after creating the instance variables, we have the constructor method. The constructor method is the way that the class builds, or the instructions on how to build your object. It's going to say, okay, the object is going to have a name, so that name will be held in a string variable. And it's going to have 3 test scores, and those 3 test scores are going to be held in 3 integer variables. Now, you do not need just one constructor. The constructor can have, the class can have many constructor methods. In this case, the student constructor does not have any parameters. When the student creates the class, when he says student s1 equals new student and does not enter any parameters inside the parentheses, then the name is going to be blank and 3 zeros are going to be put into the 3 test scores. You can create more than one constructor method. For our example, there's only one. But you can also create another constructor. But in this case, the string, it can require a string, okay, and 3 integer variables. If the person uses this constructor method, these are going to be the values. If the user uses this constructor method, these are going to be the values in that case, name is going to be equal to A, test1 is going to be equal to B, test2 equal to C, and test3 equal to D. If the person wants to create the object right away with all its values and with the state, there can be a constructor here. There can also be a constructor with other variables, as long as the state of the object is completely initialized. Okay, so there can be more than one constructor method. Now that you have the student, you created the student. Now the student has a name and it has the 3 test scores. There are other methods that we can use. And these are the behavior that we were talking about. So this is a method called setName. All these methods are used by the student app. We can use it from another class. They're not helper methods. The difference with helper methods is that those helper methods are private and can be used within the student class. As the name says, it will help the student class develop some other task at the same time. So we have the setName. Now the setName requires a string in order to work. Okay? It has a getName, and it will just return a name. It is important to understand that when you create a method, you check for what it returns. In this case, public void does not return anything. Okay? And that is the difference between mutator methods and accessor methods. Mutator methods change the instance variables and do not return anything. Different from accessor methods, which retrieve one of the instance variables or the content within the instance variables, and it must be declared differently. For example, public string means that the getName method will return a string. And at the end, if we do not return, it will be an error. You will have a syntax error saying that this method must return a result type. Okay? So it is important to understand what is the difference between mutator methods and accessor methods. Every single class that we create will have mutator and accessor methods. We also have the setScore. Now the setScore has two parameters, which I is the test number, first, second, or third, and the score. So we can set the score on each of those variables. Okay? So for every single object that we create, we can modify names and test scores, and they will be held separately every time that we create an object. Later on in this course, when we start working with arrays and array lists, we will be able to create as many objects as we want and be able to go through each of those objects very, very easily. Another of our methods is the getScore. The getScore is an accessor method, and it returns an integer value. Okay? It is important to give the client or the person and let that person understand the documentation of your class. How does each method work? Just like the Java API or the Java doc that you use all the time to understand how your methods work, like the math class or the string class. When you were using those two classes, you went to the Java doc and looked at what were the parameters needed and how they worked. Okay? Now the getAverage develops some operations inside the method. Okay? It finds the average of the 3 test scores and it returns a number. The same with getHighScore. And finally, the toString method. The toString method, it is extremely important, and every class should have a toString. What is the way that an object is presented when you want to print it? If we didn't have the toString method and we wanted to print S1, there will be nothing. We wouldn't be able to see the values that are inside S1. So the toString method, we don't actually need to call the toString. For example, S1.toString. If we want to use the toString method, we just print our object and automatically will be redirected to this portion of your code. Now this portion of the code will have a format of how you want to print your object. Okay? So I will show the name, the test 1, the test 2, and the test 3. Okay? So let's summarize. First, instance variables, all the ones that we're going to need for our class. Number 2, constructor methods. Can be 1, 2, 3, can be more than 3, depending on your needs. And other methods, where we're going to have the behavior methods. And in this case, we don't have helper methods, but we can also create helper methods if we need to do some tasks only within the student class. So we have the other methods, which are called public or private, depending on what you need. You have accessor and mutator methods. And finally, you have the toString method. Is the way on how to present your objects. Now when you open the student app, okay, here's a very good explanation of how it works. And you run the student app, as you can see, this is how you created a new object from student. We use the constructor method, the default constructor method, okay? We created a reader, okay, or a scanner in order to input a name, and then we started using the methods, okay? So this is a very interesting, and you can understand how this code works. It's very simple. It uses a for loop to enter the 3 test scores. Then it reads 1 or 2 lines. This is very important because sometimes it doesn't read your line, so it will consume the trailing new line character. Then the second student data, and finally using all the methods. If the high score is this, if the high score is that. So this is very interesting. It's a very interesting case study. You want to, you would like to, as an exercise, you would want to add some comments to those lines of code, like what do these conditional statements do, and also what does it print out. It would be interesting to add, for example, these two is the output to 2 students' information. As you can see, it prints out the student 1 and student 2, and it doesn't use the toString method. That's what I was saying. It will automatically go to the toString method and present it as it was chosen. So if you run this, we can see that we can have the first name, Nick, and the student's test scores. So I need to put in 3 test scores. Okay, so I'm going to put 80, 90, 100, and then it does it for the second student, and it will have 65, 85, 95, and then my program will display the first student with the average, the second student with the average, and it will tell me which one has the highest score. This is a very interesting case study because we are now creating classes. We are creating classes that we can manipulate and handle objects. So it is really, really interesting. It is important to understand also on your readings when you get to the instance variables and parameters. What is the difference between the local variables? Read very carefully about helper methods and the scope and lifetime of variables. Okay? You do not want to get confused with the scope and lifetime of variables. Is the time where the variables are used. Mostly those local variables are only used within the method. Okay? And the lifetime of variables and duplicating variable names can be very, very sensitive. Okay? You can duplicate any single variable if it's a local variable, if it only works within the method. You can have all your formal parameters with those same names, okay? Because they're going to be only used inside the method. Be careful that this is not an instance variable, okay? Also, it's very important that you read those about those very common mistakes on when to use instance variables, parameters, and local variables. This is going to be the base for everything that we're going to do from now on. So it is important that you really, really understand how the class works. Another thing that you need to be careful is the order of your parameters. The way that you add the parameters. Let's say on your student set score, okay? Both of them are ints, okay? So it is important the order. The first one is the number of the test, and the second one is the score. If you put it on your actual parameter in a different way, then you're going to have a totally different output. It might work because it's a logical error, okay? But you will have a wrong output. So this is what we should do with every single class. It is, I think you're going to have fun and work with your vowels or us. If you have any questions about how to implement this type of template or format for your programming activities, then please let me know and put it on your discussions, okay?